Afternoon to everyone. So today we are going to design a solar PV plant for a given load. So some customer has came to us and they has asked us that already studied this solar system. You try to design a solar PV system for the load what is having at his house. So this is the load specification has been given to us. Okay. So what is the load he is saying is having a fan. How many quantity? 3 number quantity. What is the wattage of the fans? 70 watts. And next to load given is a tubelet is there. How many tubelets are there? 3 tubelets are there. And what is the wattage he specified? 35 watts. And he told he has one refrigerator. And what is the quantity he have? One quantity. And wattage he has specified is 250 watt. The customer is asking us for this load what he has, and he specified he is operating these fans for 4 hours and this tubelet for 8 hours and this refrigerator for 6 hours. Okay, he is asking us, you try to design a solar PV plant or a solar PV system and you specify the parameters. You have to do this design. After this design, you can decide the rating of each component of the solar PV system. With this specification, you can purchase those components from the outside market and you can install to the customer. That's why this design plays a crucial role or an important role. So here the design is reverse engineering. Sir, why you are saying as reverse engineering? Generally, if you take what we need to have, first we need to have solar panel, solar PV panel. How the energy flows generally? We assume that energy flows in this fashion. First one is solar PV panel will generate the voltage. From solar PV panel, we are going to send this energy to the battery. So second one is nothing but the energy flows to the battery. So and after this energy flowing into the battery, in between you have one component which is called electronic control unit. So this electronic control unit will perform two actions, converting DC to AC or AC to DC. Okay, so that's why we need to design the third component is inverter, and the fourth component is nothing but solar charge controller, and next one, the next design is load. Like this, generally the energy flows. So how the energy is flowing is, the energy flows from solar panel to solar charge controller, to battery, and from battery to the inverter to the load. This is how the fashion of energy generally flows. But when you are designing it, you have to do reverse engineering. Why? Because we are designing. So how we'll design? Based on the load. So now first what I have to design is, first you have to design the load. From the load you have to design the inverter, and from the inverter design you have to design the solar charge controller, and from the solar charge controller you have to design the battery. From the battery you have to design the solar panel. So design is separate, energy flow is separate. I can say that design is nothing but reverse of energy flow or reverse of power flow. Okay, so you see here this symbol, this red color and black color are reverse. So black, I mean the red color indicates the original energy flow. The design indicates the black color which flows in reverse. Okay, you can see here the red color, the energy is flowing like this, but the design flows in opposite direction to that of the energy. Why? What is, when you want to design, first what you have to consider? Load you have to consider, but not solar panel. Okay, that's why the design is very important. So everyone knows how to operate, but no one knows the design. That's why very important. The design is very important, crucially for an engineer. Those who do this is called maintenance engineer. It doesn't want this much knowledge. The crucial part in any field is the design engineer. Why? Because every component, the size, rating, specification, and the way of connecting, everything is decided by the design engineer. He is a crucial part, like CEO of that company. So the CEO and the design engineer are the crucial person for the company to grow. So now coming to the design. Okay, let's try to understand the design. So now we are having clarity how to design the system. Okay, so first what you have to design? Load you have to design. From the load you have to design inverter. From the inverter, after the design of inverter you have to design an, so you can see this is an intermediate component. Okay, so first one is load you have to design, second one you have to design an inverter, third one you have to design an solar charge controller, and the fourth one you have to design an battery, and fifth one you can design an solar panel. Okay, so this how our design flows. So now let's try to design the rating of the equipment. Okay, so first when you are designing, what you have to keep it in the mind, the load. So customer has some load, for his availability of his load, or for the making that load to run for how many hours, 24/7. We want to design each individual component. So first you have to design the inverter, second you have to design the charge control. There's no need to design the load, already load is available. So from the load we have to design the inverter rating, from the rating of the inverter you have to design the rating of charge controller, from the rating of charge controller you have to design the rating of battery, from the rating of the battery, you have to design the rating of solar panel. After deciding all this rating, you have to purchase this equipment from the market. So you can see this design. All the design I will take and I will round off to an higher figure or lower figure. Why? Because in the market, for this load, no one will manufacture an inverter. So either market will manufacture either a 400 VA or 800 VA or 1.5 kVA. So no one will manufacture 200 VA, 100 VA like that. Okay, so whatever matches nearer to the market rating, you have to purchase or procure that equipment. So that's why I'll round the figure. Don't think sir, calculation part you are rounding the figure. Rounding the figure is I'm rounding as per the availability of the market, such a way that you can purchase it and you can install to the customer. So coming to the first design, so load we need to calculate. You see here, let's try to calculate the power required by the load as well as the energy required by the load. What is meant by energy? Energy is nothing but the product of power multiplied by the time. Power into time automatically will give the energy required. This is very simple. One more logic you see here. The output of the inverter is the input to the load. Yes or no? The output of the inverter is nothing but input to the load. So the output of the charge controller is the input to the inverter. The output of the battery is the input to the solar charge controller. The output of solar panel is input to the battery. Are able to understand? In this sequence you have to analyze. So first you have to calculate load. From that load, the output of the inverter is input to the load. So the output of charge controller is input to the inverter. The output of the battery is input to the charge controller. The output of solar panel is input to the. Sir, how all these are linked? All are linked by a mechanism called efficiency. Efficiency is defined as a ratio of output power by input power. Okay, so their output is there, input is there. Efficiency is already known to us. Okay, let's try to calculate. So you see here, everyone take your calculator and do parallelly with me. So here we have fans. How many fans are there? 3 fans are there. What is the rating of the fan given? 70. So multiply this. 70 into 3. 70 into 3 is how much? How much? 210. 210 watts. Next one, how many tubelets are there? 3 tubelets are there. 3 into 35. 3 into 35 is how much? 35 into 3. 105 watts. How many refrigerators he is having? One refrigerator, and each refrigerator rating is 250 watts. So 250 into 1. Into 1 is how much? 250 watts. What is the total power rating? 210 plus 105 plus 250. Add individually. Everyone do it. 2 560 565 watts. But this is what the power required by the load. But we need to also understand, in order to design the rating of a battery, you need to understand how many hours it has to give the backup. That's why we have to calculate the power rating as well as the energy rating. Okay, so coming to here, so this 210 watts is operated for a time of how many hours? 4 hours. Now multiply 210 into 4, 840, and what will be the units? Voltage into current. What you can write down? Watt, and it is multiplied with hour, watt hour. Now 105 watts multiplied with 8. Multiplied 840 watt hour. Next 250 into 6, 1500 watt hour. So this is the energy required by fan load, this is the energy required by the tube light, this is the energy required by the refrigerator. We have to add all the energies that is required by the load. Add 840 plus 840 plus 1500, 3180 watt hour. Now you are very clear that this is the energy required by the load. Okay, so load is requires this much amount of energy. This energy has to be supplied by what? This is the energy required by the load, or this, or I can call this as load demand. The load what I may have, this energy has to be supplied by whom? The inverter. So I can say this load demand also as an inverter output. Yes or no? The inverter output has to supply this much amount of energy. Yes or no? Now, and this is the power rating. Now we want to design. Now load is very clear. So this is the power rating of the and this is the energy rating of the load given. So this is the load output, or this is also called inverter output to be delivered. Okay, now we have to design the inverter. So coming to the second, which is nothing but the design of inverter. Design of inverter. So already we know that inverters are power electronic based. They convert AC to DC or DC to AC, which are called as an converter. But rectifier also it can perform. Why? Because it's a converter. Okay, but now we need only one operation, which is not the converting an DC to AC. Okay, I am assuming the manufacturer generally specified the efficiency of this inverter is 93 percentage. Okay, how to write down 93 percentage? 93 divided by 100. How many zeros are there? 2 zeros. I can write down this as 0.93. So now I want to calculate what is the input energy I have to supply to the inverter. What is the inverter output you got? 3180 watt hour. So this is the energy output of the inverter. So here I have to calculate in order to give this much amount of output, how much amount of energy I have to give input. Okay, so I have to calculate energy as well as the power. Now efficiency of the inverter is equal to output power divided by input power. I will calculate power as well as the energy. So what is the output power of the inverter? What is the output power? So this output energy, this is output power. So what is the output power required by the load? Is nothing but inverter output. What is the power required? 565 watts divided by, you see here, input power. So input power is, we need to calculate, but what is given in the problem? Efficiency is given as how much? 0.93. So from this formula I can determine the input power is equal to 565 watts divided by efficiency is how much? 0.93. You see here already we have a basic relation. Try to do it. 565 divided by 0.93, the value will increase. 607.55 watts. But generally if you go to a market, an inverter may not be available with 607 watts. Okay, we are going to round it and we are going to buy an inverter rating of how many watts? 600 watt inverter, or generally the public call this as a 600 VA rated inverter. Okay, so it is recommendable to have to buy 600 VA, or if you are too much, you want to invest for a future load, you can buy 700. But generally we'll design the problem only for this problem. Okay, so overall design will generally change, but when you design for a problem, we want to select as per the given problem. I'm selecting only 600 VA. But in open market, when anyone asks, we'll ask them to buy 1.5 times of their load. Why? Because in future the load may increase. That is a general thumb rule. Now, what is the rating of the inverter? What is the rating of the inverter? So now we design an inverter. The rating of the inverter we have to buy in the market is how much? 600 VA. And we need to calculate, and we have a formula. The relationship between input power is equal to output power plus losses. From here only you can understand which is greater, which is lower, always input power will be greater than compared to output power. So I can say that input power is all the time greater than compared to output power. Yes or no? Why? Because input power has to supply output and losses. Just you verify it whether it's happening or not. So what is the output power? Output power is how much? 565 watts. But how much input it has to supply? 608. Is the thumb rule satisfied? 607 is greater than 565. This is a good design. Okay. Now we calculate how much input power we have to supply to the inverter. Similarly, you have to calculate how much input energy has to be supplied by the inverter. So coming to here, the same formula, efficiency is equal to energy output of the inverter divided by the energy input of the inverter. So the energy input I require, energy input of the inverter is equal to what is the output of the inverter in terms of watt hour? How much? 3180 watt hour divided by, already the efficiency given by the manufacturer is how much? 93%. I am converting into percentage as 0.93. And now what is the input energy to be supplied by? Input energy to be supplied by the inverter. Louder? 3409, 3000, 19.35 watt hour. So approximately this is 3500. But generally if you go to the market, if you ask this much energy rating I want inverter, they will not give. They will ask you what is the power rating. What is the power rating of our inverter? 600 VA. Now successfully we designed the output of the inverter is how much? 3180 watt hour. And what is the output power of the inverter? 318. From this we calculate how much input power we have to give to the inverter is how much? 600 VA. And how much energy is? 3420 watt hour. So this is the input energy we have to supply. So here we are going to calculate. So the input energy we need to supply to the inverter, and input power we have to supply to the inverter is 600 watts, and this one is 3420 watt hour. So now we need to calculate this charge controller and battery and solar panel. So try to do this part. We will continue with the calculation.